So we'll start. So we talked about the two supers, right? To call the base class method. We talked about overloading a bit. We talked about overriding. We said in Java, the polymorphism happens by default. We don't have to say anything, unlike C++ where we have to say virtual. Java, depending on the type of object we are pointing to, polymorphism happens. Okay. So today, what we'll do is, we'll create a example based on what we did in the last class, and then take it forward. Okay. So we'll create a class called animal, and we'll create two derived classes from it called elephant and let's say tiger. Okay. We'll create two derived classes, and then we'll play with it, and then you'll understand. We'll go a little more deeper. So I think you can open day 7 Java Lab 1 if you need our code. Okay, so we'll start. So we'll create a class animal, and you will see some interesting things about that. Class animal, then we'll add two methods in it. We won't add a constructor, so the default constructor will stay, and we'll add two methods. One is eat and one is talk. I don't know whether animals can talk, but let's keep it there. So we have an eat method and we have a talk method. So public void eat, public void talk. No, don't make it public in the beginning. Just keep it as eat. We'll see what, yeah. So just say animal eat, eat of animal called. And talk of animal called. Yeah. And we'll say talk of animal called. Yeah, we are done. So our class animal is kind of ready. It has two methods, eat and talk. Okay. And we will now create, so class animal is fine. Now we'll create a derived class from class animal. So we'll say class tiger, yeah. It will also have an eat and a talk method, which we'll copy from there. Only thing we'll do is change eat of tiger called and eat of tiger called. We'll say class tiger extends animal. So it's a derived class of animal. Similarly, we'll create a class elephant, which is very similar to this class. Extends animal, and eat of elephant called and eat of elephant called, talk of elephant called. Okay. So we have these three classes. If I were to show the hierarchy diagram, I would have animal class, and from that we have two derived classes. One is tiger, one is elephant. Okay. Now I think we are ready to start playing with this. Class test, then we'll have public static void main. Yeah. Now we will instantiate a few things, and you will help me do some of these things. So I will say animal A, okay, semicolon. Is this allowed? Not allowed? Is this allowed? No, yes. What's wrong with it? Perfectly fine. What does it do? It doesn't create any object. It just creates a reference. We saw this. It just creates an animal reference. That's all. A as animal reference. Now, A is equal to new tiger. Is this allowed? A is of animal reference. and I am pointing it to a tiger object. Tiger object is getting created on the heap, right? Is this allowed? Is it allowed or not? Perfectly allowed. By what law? Base class reference. A is a base class reference. Can it point to a derived class object? Yes, very much. Now, is tiger a derived class object of animal? Yes. We just said no. Okay, tiger extends animal. We said that just now. And also elephant extends animal. So there are two classes derived from animal, elephant and tiger. So A is equal to new tiger. So that is perfectly valid. Now I will say A dot eat. A dot eat. Which eat will be called? A is an animal reference. It is pointing to a tiger object, as you can see. And then I am saying A dot eat. Which eat will be called? Animal seat or tiger seat? Tiger seat, because this is where we stopped last class. We said that polymorphism is natural to Java, which is not very natural to C++. We have to force it by saying virtual. So here it's natural. So who is morphing here? A is morphing. A is now started as an animal reference. Now it's pointing to a derived class object, which is allowed to do. A base class reference can always point to a derived class object. And then can I now say A is equal to new elephant. I can still say this. Yes, no. By the same token. Okay. And then I'll say A dot eat. So now can you see the morphing happening? Morphism means changing form. Do you see that happening? No, yes. Because that's what is happening, isn't it? A started as an animal reference, right? Line 28, it became a tiger, it was pointing to a tiger object. So eat of tiger got called because it's pointing to the tiger object. Then we made it point to elephant object and A dot eat got called now. So, okay, so let's understand what is the output just to confirm. Okay. And we will, okay. So, as expected, eat of tiger got called first time, then second time eat of elephant got called, as was expected. This is what is called polymorphism or runtime binding. So depending on what it points to, the decision is made at runtime as to which method to call. So because on line 28 at runtime, A is pointing to a tiger object, it is A dot eat. Line 29 is calling the tiger reference, tiger eat and elephant eat. Okay. Now this is at very fundamental level of polymorphism. Now why is this so important? Why am I spending such amount of time trying to show you the idea of a base class reference pointing to derived class object and then showing the polymorphic behavior? Why am I doing that? There is a reason for doing that. Why polymorphism is so crucial, so important to the whole idea of object orientation, inheritance and all that. Now suppose I were to create a zoo and my zoo was two elephants and three tigers. 2 elephants and 3 tigers. Okay, that is my zoo. So how would I declare a zoo? How would I create the zoo? Okay, but before that, just one point before that. How many objects have been created in this code so far? How many objects have been created? 2. Everybody clear? There are 2. All. Okay. Now if you were to visualize, and at this stage it's important, what's happening in memory. So there are 2 objects, but there is a small problem. Okay. So I'll draw the heap for this code. This is my heap, the memory heap. On the memory heap, first I created a tiger object. Okay. Tiger object. And A was pointing to the tiger object. A was a reference. References are generally created on the stack. So A was pointing to the tiger object. Then I created an elephant object. That was the order, no? First tiger, then elephant. So then I created another elephant object. Okay, this object. And then now A is no longer pointing there, A is pointing here. So what happened to this object? This original tiger object which I created, what happened to it? It is sitting there right now in memory heap. Now, if it were some other language, this would lead us to trouble. This would make it a memory bleed or a whatever, memory leak, whatever that kind of. Will that happen in Java? No. Why will that not happen? Because what Java will do is, inside Java, there is a JVM, Java runs with a JVM, Java virtual machine. Within the Java virtual machine, there is something called a garbage collector. Now, what is this garbage collector all about? We'll talk about it at length later, but at this stage also you should start developing an idea. At the garbage collector, what it does is, at this stage, whenever it is called, now can you control when it gets called? No. If at all it gets called, that depends on a decision of the JVM on which actually we don't have any control. So, what does it look for? It looks for objects which are orphaned. What do you mean by an orphan object? An object which has no reference pointing to it. The original tiger object, for example, is an orphan object. They also called such objects in literature as eligible objects. Now you will say, eligible for what? To get married? No. Eligible to get collected, garbage collected. So it's an eligible object for garbage collection. Which one? The first one. Now whether it will actually be garbage collected, whether it will be added to the free pool or not, that we can't say, nobody can say, because that is completely under the control of the JVM, and you cannot tell the JVM that you collect this garbage. It decides on its own. You can suggest to the JVM, but you cannot tell the JVM. There's two different things between suggesting and commanding. You can only suggest to the JVM. There is no way the JVM can guarantee that this object will be garbage collected. But rest assured, at some stage, the object will be garbage collected. When the JVM runs short of memory or something like that happens, it will collect this, but you can't really control when will it happen. But I think it's important to understand that there is going to be a bit of garbage collection in this program so far. Okay, let's go back to the code. Now, as I was saying, my job right now is to create a zoo. The zoo has 2 tigers, 3 elephants or whatever. Let's make it smaller. Let's say it has 2 tigers and 1 elephant, so that we don't have to declare a big array. Okay, so 2 tigers and 1 elephant. Okay, so that is our zoo. Now the question is, how will I create this zoo? Will I create, obviously I need to create an array. Which array will I create? I'll create an array of animal, because if I create an array of tiger, elephants can't sit in it, and vice versa. If I create an array of elephants, tigers can't sit in it. So this is where polymorphism's biggest power comes, because I have seen a lot of people, they don't understand why polymorphism is so crucial. Now you will begin to understand why I am using polymorphism and what is the power of Java's polymorphism. So if I have to define a zoo, let's define a zoo. You remove this code, 27 to end. So let's start creating a zoo. So I'll say animal, correct? Animal, zoo, square bracket, semicolon. Okay. I can do many things in one line, but I'm not doing it. What does this do? Does any object get created right now? Not even an array object? No? No. Nothing gets created at this stage. Only thing is, a zoo reference gets created. So this zoo reference can point to what? Any array of animal objects. Remember, it can point only to an array of animal objects. It can't point anywhere else. Okay? So now I'll say zoo is equal to new animal 3 square bracket. So again pause. How many objects did I get created? Yes? How many objects have been created? No, 0 object, 3 references. No object is created. I said new, no? Array object is created with null references. So what got created at this stage is one object got created. What kind of object? Array object. But how does it look? Okay, this is how it looks. Now on the heap, an array object got created with 3 slots, and our zoo refers to that array. It's a reference to that array. So slot 0, slot 1, slot 2. Now each of the slot at the moment is null, the small null. All 3 are null at the moment. But there is one object for sure created on the heap. Okay? Yes? We do have an object created on the heap. It's an array object with 3 null references. Okay? Numbered 0 to 2. Okay, now let's go about creating the zoo. So I'll say zoo of 0 is equal to new, I'll say tiger. So this is a tiger. Then zoo of 1 is equal to new elephant, and zoo of 2 is equal to new of tiger again. Okay. Now we got 2 tigers and an elephant. So how many objects so far? In this program, how many objects so far? 4. One array object, and then each of the reference pointing to accordingly tiger or elephant object. So let's draw the picture of our memory, or continue with the picture of our memory. So now this is no longer null. This is pointing to a tiger. This is also pointing to a tiger. Second one is an elephant. Third one is again a tiger. Okay. So this is the structure of my memory at the moment. Everybody with me? 4 objects are being created. They are all sitting in an animal array, which is a zoo. Now let's look at the code. And okay, now this would not have been possible without polymorphism. Do you agree? If I didn't have a base class concept and a derived class concept, I would not have been able to create a zoo at all. Because the obvious question will be, what kind of zoo will I create? Zoo of what? Zoo of something in which tigers can also reside, elephants can reside, snakes can reside, whatever can reside. It has to be something which has the intrinsic properties of all these classes, which is a base class of all these classes. This is another advantage of inheritance, that if somebody asks you to create an array of a certain category of objects, you always create an array of the base class, because then the base class references can point to any of the derived class objects. You can accommodate any of the derived class objects. For example, let's say I am creating a college. In a college there are different kinds of students. There are undergraduate students, there are postgraduate students, there are doctoral students, there are diploma students, there are certificate students, whatever. There are n different categories of students. How would I do it? I would create a student class, then I would derive from the student class a UG student, a PG student, a doctoral student, a diploma student. I would derive all of that. But when I create that in my program, I would create a program of student, array of student. So that is how we do zoo 0, zoo 1, zoo 2. Okay, now you see the power of polymorphism again. Now we'll create a loop for each animal A, the for each loop, for each animal A in zoo. This is how you read it. For each animal A in zoo, what do? We say that A dot eat, correct? Now we are calling a method A dot eat, correct? Yes, no? Okay, so I have a method A dot eat, and what will happen? Will polymorphism happen? Yes, because I am using an animal reference all through. Each A is an animal reference. Using that I am pointing to each of the derived class objects. So their individuality will still be around. still be exhibited. So let's run it and see what we get. Okay. So we'll run it and check. So we got whatever we are supposed to get. So as expected, eat of tiger got called, eat of elephant got called, and again eat of tiger got called, because that is how my zoo is. The first animal is a tiger, second one is an elephant, third one is again a tiger. So that's how the invocation happened. Okay. So we'll move forward. Okay. Everybody with me so far? No? Yes? So we have understood what? We have understood how to create an array of derived objects by creating an array of base class references. This is the moral of the story, because this requirement will come very often in programs where you want to create, for example, another example could be employees. You know, there are different kinds of employees, full-time employees, part-time employees, contractual employees. These are all, will create a class of employee, base class, from which full-time, FTE, PTE and CE, contract employee, all of these will come from that, right? So we can create very similar concepts to handle that kind of data. So this kind of handling of data has to be very common and should be familiar to everyone. Now we take our first major step today. Now we introduce the idea of an abstract class, okay, which we wanted to do it last class but didn't. This is a basic treatment of how arrays are created and all of that. Now we have not talked about two-dimensional array, but I'll come to that. Now we will start talking about a little bit about why there is an abstract class. Okay, before we talk about why there is an abstract class, the justification, you know, what is an abstract class? An abstract class, you may know, remember, those of you who remember, from C++. What is an abstract class? Yes. Yes. But what is the essence? What is the essential property of an abstract class? Yeah? Acts as a template, all that is right, but what is the essential definition? Polymorphism is also right, but what is the essential characteristic? Yes? Pure virtual is a mechanism, but why do we need abstract classes? What is its, if I were to say abstract class, what should come to your mind immediately? First thing, all that you are saying is correct. Instantiated. An abstract class cannot be instantiated. That is the essential characteristic of an abstract class. That means I cannot say new on that class. Such a class is called abstract class. Correct? Then how do you make an abstract class? You have a pure virtual method, all of that. All of that is the technicality of how to make it happen. But I want a class whose instances don't exist. I don't want to exist. Now you'll ask, why do you need a class in your program which cannot be instantiated? Why such a animosity, such an anger towards an abstract class that you don't want it to be instantiated? That is, you don't want to say new on that object. You can't create an object of that class. Why? Why such animosity against an abstract class? Now, I have said what is an abstract class, besides other things, a class which cannot be instantiated. Now, why would you want a class in your program which cannot be instantiated? I mean, do you want it for decorative reason? Or is there a particular reason why you would want a class in your program on which you cannot say new? Is there an argument? Yeah? Hiding implementation detail is the nature of object orientation. Why would you need a class which cannot be instantiated? Because it is incomplete, right? Abstract classes serve a basic purpose in design. See, when we design classes, somebody sits with pen and paper or machine and starts designing a class. when he is designing that class, there is every possibility that he has not fleshed out that class completely. He may have decided that this class will have 7 methods, but at the moment he is not ready to write the logic for all the 7 methods. He would like his derived classes to supply the logic. He won't want the base class to supply the logic. Such need comes often. That is, when we have a need for a class, I want to write part of the class. That is part of the behavior I want to write. Let's say there are 7 methods in this class which I want to have. But you know what? Though I want this class to have 7 methods, I want to write only 3 of them, and the remaining 4 of them I want to not write. I want to write some dummy body or not write them at all. Why don't I want them to be written? Because at this stage, I know that these methods are needed on animal, but I don't want to get into the actual body or implementation. I want to leave it to one of my derived classes. That is, it's like saying, I want to create a skeleton and a design skeleton, and which will be fleshed out by my derived classes. But I want to keep the scaffold or skeleton or whatever, the structure ready, but it has to be substantiated by the derived classes. This need comes very often in object orientation. When you are doing design of big projects, you cannot flesh out everything at the beginning. So what do? You flesh out whatever is required at this stage, mention the other methods, but refuse to provide or supply an implementation of those methods. You say, let the derived classes do it when they actually are written. I will not do it. So when you have a need, and such need comes pretty often in any reasonably big design project, where we want to have a kacha definition, you don't want to make it completely frozen at this time, leave it incomplete, partially complete, and then forget about the rest. So when that need arises, and that need arises pretty often, so the important point that comes is, I want to have the provision of incomplete classes, partially defined classes. So in order to fulfill that important requirement for design, they have introduced the idea of abstract class. Now, how do you make a class abstract? That for a C++, what do? You say, you create a virtual method and assign it to 0 and call it a pure virtual method. You can do it something like that. Different languages have different other ways of doing it. Java has a more straightforward way of saying, you say the method is abstract, and then say that this is an incomplete class and it will be completed by the derived class. See, we have created the hierarchy. You should take the hierarchy and elaborate. Okay, now let me go up. Okay, now I am going to write an abstract method in our animal class, and I am going to make it abstract. Okay, now I'll say void walk. Okay, I don't want to write the body for walk, but I know animals can walk. But I don't know when I'm creating the animal class whether there should be a walk, whether it should do something. Unlike eat or talk, where I have given some body at the animal class, so if the derived class doesn't provide that body, it can inherit this. Whereas for walk, I actually don't want to supply a body. I want to say that an animal can walk, that is what I have said, but I will not provide the body for walk at the animal stage, because I believe that this should be done by the derived classes. So I will say walk. Now because I mark a method as, I want this method as walk, if I write like this, Java will not like it. Java will say, what nonsense, where is the body, right? So I cannot get away with this in Java. So what will I have to do? I'll have to mark this method as abstract. Okay? And Java says, if you mark any of my methods as abstract, any of the methods in a class as abstract, what do you need to do? You need to mark the class also as abstract. I will not allow this. If you try to compile the code at this stage, it will say, you seem to have an abstract method in your animal class, but you don't seem to have declared the class as abstract. Okay. Now, I'll mark the class abstract. Okay. Now, okay. So what do we have? We have a class abstract and we have two derived classes, tiger and elephant. They have two methods each, talk and walk, talk and eat, which they are overriding the base class methods. But now our base class, which is animal, also has one more method called walk, which has been marked as abstract, and this method walk is not there in tiger or in elephant. It is marked as abstract in the base class. Now my first question is, do you think this code will compile without checking? What do you think? Will it compile? Will it not compile? Forget C++, here. It will compile? Or do you think something sucks? Something is wrong? See, my base class is what? Animal. Look from tiger's side. Now, it's an abstract class. In a way, it is an incomplete class. Now, I am tiger. I am derived from animal. My animal is incomplete. So, doesn't something sound very peculiar, very disturbing to you? Develop a taste. Does it look disturbing? I am inheriting from an incomplete class, from an abstract class, an incomplete class. Where is its incompleteness? It has a method called walk, which is not there. It is just marked as abstract. I am deriving from it. Do you think I am complete? I mean, does it sound complete? No. It doesn't sound complete for the simple reason, tiger is derived from animal, elephant is derived from animal. So if they are supposed to call themselves complete and get instantiated, then they should finish or complete the uncompleted agenda or the unfulfilled agenda of the class they are deriving from. Tiger is an animal, elephant is an animal. Animal is incomplete because it has a method walk, which isn't there, which is abstract. It is meant for later definition. So I am sure everybody will agree that class tiger is not yet fulfilling the unfulfilled agenda which it has inherited. It is coming from animal class. Animal class has something unfulfilled, unrealized, unimplemented, and that is the walk. It is not there. It is supposed to be there but isn't there. So at this stage, both tiger and elephant will not be allowed to complete. Why will not be allowed to compile? Java is going to tell us, array, you are deriving from a class which is incomplete. Either you complete the incomplete agenda or declare yourself as incomplete. But you declare yourself as incomplete by saying you are also abstract. What will happen? Then nobody can say new on you. Right? Now nobody can say new on animal, but we aren't saying new on animal. We are creating only an array of animal. We are never saying instantiate animal class. So there we are fine. But when it comes to tiger or elephant, none of these classes have decided to complete the incomplete agenda. So what right do they have to call themselves complete? What right do they have to say that you can instantiate myself? You cannot, because you are not completed. You inherited an unfulfilled agenda and you have not completed it, right? So, okay, now you will get an error. Just watch the error. Yeah. So, if you can open up, you see there, class tiger extends animal. What Java is protesting is, he's saying, or Java is saying, tiger is not abstract and also does not provide a walk method. So Java is indirectly telling you, either call yourself abstract, then I'll allow you to compile, but I'll give you error when you try to instantiate, or better still, fulfill the unfulfilled agenda. Okay, that means compulsorily supply the method for walk. Okay, so we will do that. Okay, so we will say walk. Now we'll talk a little bit about why we wanted that to be there. So I am having walk here, and I'll have walk in elephant also. Good. Okay. So now we have completed. Now we can call. Now on animal, okay, come down. Now on animal, we can also call eat as well as we can call walk, which we just added. No problem. Though animal is an abstract class, we are never instantiating animal. We are creating an array of animal references, but we are never instantiating animal. So here we go. Let's try it out. Okay. As expected, we got eat of tiger, walk of tiger, eat of elephant, walk of elephant, and again eat of tiger and walk of tiger. This is as expected. We got it. Now we are going deeper. Now think. Okay. Now you will ask, okay, go back to animal class. Okay, what did I achieve by marking that walk as abstract? What did I achieve? I achieved a certain discipline. Now you'll ask, what discipline? I ensured that all those classes which derive from animal compulsorily must have a walk method. Didn't I do that? If they don't have a walk method, they will have to become abstract. So if I have a concrete class, which is a non-abstract class, compulsorily that class must have a walk method. If it doesn't possess a walk method, it cannot be a derived class of animal. Have I not enforced it? And I have also supplied two methods, eat and talk, which are the original two methods, which you can inherit. Even if elephant or tiger don't write their eat or talk, that is fine. But they will compulsorily have to write the talk method. Why? Because it is abstract. It has to be supplied. If you don't supply the talk method, the elephant class and tiger class are useless. Useless in the sense they are abstract. They will have to be marked abstract. Okay. Now, let us go little deeper there. Now you are having an abstract class and an abstract method. Okay. So now look from a designer's point of view. So one option is, as I mentioned before, I create a nice abstract class. I write nice 4 or 5 methods, like I have written eat and talk, which either can be overridden, or if the derived classes don't want to override them, they can use these methods directly. Okay, they can inherit the methods. And I also have a method like walk, which is incomplete. Animal class says, I am not going to write the walk method. Only the derived classes must supply the walk method. I will not supply the walk method. So now, what does this all mean? Okay. Now, this is one option of how do you design base classes. Some of it concrete, some of it incomplete. What is complete? The eat and talk are complete methods, and walk method intentionally left incomplete. Now, there is an elder brother of this concept, where people generally don't see the connection, but this is important to understand. Where a designer says, look what, I want to create a class, a so-called class, where I will not supply the body for any method. I will say, all my methods I am going to mark them as abstract. What do you mean by that? What do you mean by that is, I am only going to create a policy that any class which derives from me has to have these methods. So, I want to create a class which is not partially incomplete, but completely incomplete. That is, I don't want to provide the body for any damn method. Now, I only want to provide the names of the methods so that I can be used for inheritance purposes, but I will not provide body for any method. There are people who will design base classes keeping this in mind. Now, when will they do this? When will they do this is when they only want to define a structure. They don't want to provide any logic. They just want to say this particular class is all abstract. It has all abstract methods. I am not going to give any body, but I am going to insist that each of my derived classes provides each of these methods. By doing that, I am enforcing a certain discipline on all my derived classes. Now, why would I do that? So that I can treat them collectively as I am doing in an array. So if I want to do that, there are two options of doing it. What will I have to do? Now look at the first way of doing it. I want this entire class to be abstract. Now Java will say, you can't do this. Decide. Do you want this method to be abstract? What is wrong with that? If you are marking a method as abstract, at the same time you can't have a body of that method. You either decide you want a body, then give a body. If you want it to be abstract, mark it abstract, don't give a body. So I'll have to remove the body, otherwise it won't compile, it would be an error. Okay, so I take off the body. Same thing I do with talk also. So now, what does it mean? It means that any damn class which has to inherit from these classes and wants to be non-abstract must compulsorily do what? Provide body for all the methods. Can they be invoked from an animal class reference? Very much, because it's an abstract class, but it can still have references to abstract class is not prohibited. You can still have. You can address, you can create an array of animal references like we are doing right now in our code, and it will still work. Now, will our program still work? Absolutely. Because each of our derived classes has a eat, has a talk, has a walk. So no problem at all. Each of our derived classes is going to work because they are all having these three methods which are mandatory. Okay. Now, we'll still try it out for completeness. Let's run it and check whether it's working or not. You will see it's working nicely. As expected, the same answer, whatever that. Now, okay. Now, go back. Have you understood this? Everything is abstract. I don't have a single method. Every method is abstract, the class is obviously abstract. Even if one method is abstract, class is abstract. Here all methods are abstract. Now, look at this line 1 to line 5. Okay. Now there is a jump. This is how the thinking, I am just tracing the thinking. First, they created abstract class. Then people started writing this kind of class. Obviously. Now, obviously, the designers of Java went and talked to these people who are using it this way. They asked, why are you doing it like this? So obviously, the designer said, look, I want it this way because I want all my derived classes to provide body. I am only going to provide the skeleton. I am not going to provide any body. And this is a very common requirement. So, James Gosling, who created Java, he obviously talked to a lot of people who were using C++ in this way and said, oh, this requirement seems to be coming very often. Why don't I introduce a feature which kind of takes this requirement, makes it simple. That is how, which idea took birth? Very good. The idea of the interface. They now used, Java guys started using this word called interface. Now you'll ask, what the hell is an interface? What you're just seeing on the screen? No, yes. An interface, the other version of an interface is a class in which all methods are marked as abstract. So instead of using this construct for animal, I'll comment out that construct for animal. Okay. And I'll make a few changes. I'll say, instead of saying abstract class animal, I'll say interface animal. Now I am converting animal into an interface. So how does a class become an interface? When all its methods are abstract, then that class becomes like a interface because it has nothing else. It is just a shell which is saying all my derived classes should have these methods, nothing else. Okay. So I'll say interface animal, void eat, void talk. The return type remains the same obviously, and void walk. Okay, done. Now there is a small problem I'll get. Okay, I'll have to make changes to my derived class. Now, do you understand the correspondence before we go to the idea of an interface? Are you understanding? No, just go up a bit. Yeah, see that line 1 to 5 and its replacement with line 6 to 10. That should be crystal clear in your mind. What is an abstract class and what is an interface? A class with all the methods abstract can become a interface. I mean, that is how the idea of interface was created. That there is a need for a base class which is abstract, but all its methods are abstract, nothing else. No method is fleshed out. It's only a structure. It's only a list of methods which that interface must have. Okay, now there are two changes here we'll have to make in our derived classes. Now, a class tiger extends animal when animal was a class, an abstract class earlier. Now I can't use the word extends with animal. I have to use, because animal has turned into an interface. Now I have to use the word implements. So a class implements an interface. Okay. And same thing we'll have to do with elephant also. Implements animal. Nothing else. One more change. Did you understand the change? This is about the syntactic thing. For some reason, the designers of Java said it should be implicit in the definition. They are also extending only, but we don't use the word extending. Extending is reserved for classes. It is not used for interfaces. For interfaces, we say implements, which is understood that what comes after implements is an interface, and I have to provide body for all the methods in that interface with a small caveat. Okay. So I have class tiger implements animal. Now there is one more small change which people don't remember, forget often. It is like this. When an interface is created with those abstract methods, eat, walk and talk, all those methods are by definition, by law, public. So these methods are marked public, though you don't see public there. So there, can you see a hidden public before on line 7, 8 and 9? I can't, there isn't. It is understood that all methods of an interface are public. And when you implement those methods, the class which is providing the methods, in this case tiger and elephant, must provide the word public for every method. They should not. So right now my class won't compile. Class tiger won't compile because it is not marked the methods as public. The Java compiler will crib. He says you are implementing an interface, and interface has all methods which are public. You are not giving public keyword, so I will not compile. So see the error. It's important to get that error. So we'll get that error. Okay, we see the error. Now you will see walk in tiger cannot implement walk in animal, because walk in animal is public. Public means available to everyone, and a class which is implementing that interface cannot reduce the availability. Public is the most available. So it also has to say, I am also making this method most available. So I will mark it as public. So we will put public here, public here, public here, and everywhere. Okay, now those errors will disappear because I have marked them as public, and now you will see as expected the rest of the output. Okay. No, just see the output. Same output. Now if you come down below, just to look at it again. Yeah, come down. Okay, now if you look at line 36 now, what is animal? Animal is no longer a class, remember? But am I changing any of that code? No. That is important to understand. Though I have transformed from a class to an interface, I have not changed a single line of code in the main. Not a single line. That is the beauty. I transform that whole class first to abstract, then to interface without any change to the main, because I retained the basic flavor of the animal class, that it has walk, talk and eat. So now you see line 36, what is it creating? It is creating an array. Array of what references? Interface references. Now if you see line 37, zoo 1, zoo 0, what is left hand side? What is zoo 0? It's an interface reference. Zoo 0 is not a class reference or an object reference, it's an interface reference. Zoo 0 is animal 0, which is an animal is no longer a class, animal is an interface. So I am using a zoo reference, a reference on the left hand side, an interface reference on the left hand side. Now it's not a base class reference, it's an interface reference. Now interface reference is pointing to an object. Now that is allowed because the object on the right hand side of line 37 belongs to a class which implements that interface. As long as that class implements that interface, I am fine. I can always point an interface, use an interface reference to point to that object. This is very much allowed because tiger or elephant, both of them implement which interface? Animal interface. And I am referring them through zoo 0, zoo 1, both of which are animal references, or zoo 2. They are also animal references. They are interface references, but they are pointing to classes which pointing to objects where the class implements that interface. Okay, this is perfectly fine. Now we will move further. Okay, so we have brought now the idea of an interface. So for you to make sense, the interface reference has to be there, interface has to be there. Then in line 11, you have to use the word implements instead of extends, and you can also use, you have to also make the methods in the interface which you are implementing public. You have to give, when you give the body, you have to mark the methods as public. That is mandatory. This is all basic Java. You need to know this inside out. Okay. Next, we come down. Okay. Now, we'll come to two important rules. Okay. Let's think about both the rules. First rule. Actually, both are similar rules. Now, a class in Java, now this is an important rule, and it varies here from C++, but I don't know, maybe this is a good time to explain, but you'll have to listen very carefully. Okay. Now I am going to describe, see this part, some of you will follow, some of you it will go over the head, but I need to do it because it is necessary. I would be not doing correct job if I don't show you this. But this will take a little thinking on your part to fully understand. Okay. Now, I am going to compare, okay, I will compare multiple inheritance of C++. Let us just comment on multiple inheritance of C++. Let's say there is a class A, there is a method M1, there is a class B, there is a method M1, there is a class C which derives from A and B. Okay, let's say this is M2. For time being, let's say this is M2. Then in C, if I create an object of class C, C1 is equal to new C. Okay, wrong name. I can say C1 dot M1 and I can say C1 dot M2. Now, lot of people who like C++ will say, this is beautiful. I have two classes A and B. I am deriving from both the classes A and B. I am class C. And I am creating here which is derived from A and B. And look at the way I am getting the benefit. I am getting M1 from A, I am getting M2 from B, and I am able to invoke on an object of class C, which is C1, both M1 and M2. So I am getting these behaviors partly from A, partly from B. Of course, we know this leads to problems later. We'll talk about it in a moment. But prima facie, if you really look at people who use C++ quite a bit, they say this is a beautiful thing because like this I can inherit from multiple classes. Multiple inheritance doesn't stop with two classes, right? I can inherit from multiple classes, A, B, X, Y, Z. I can get behaviors from all these classes without writing nothing. I can straight away make my class C inherit from 10 other classes and I can get their behavior, correct? Now, Java says, I don't tolerate any of that. I don't support any of that. Java says I will support only single inheritance. I will not support multiple inheritance. And believe me, Java came about 8 years later than C++. Generally, the languages which come later are expected to be more mature, more sophisticated than languages which come earlier. Here is a situation where Java, which came later, decided to say, I don't want multiple inheritance, though apparently, if you really look at it at this level, it seems like a very good feature, and the argument of Java that I don't want this feature appears to be very incorrect, isn't it? Because you are suddenly saying, you can't do this in Java. You can't inherit from more than one class in Java. You can inherit from one class only. Because the extends keyword doesn't support a comma. Yes? Extends keyword doesn't support a comma. And so, you have only one class. So, in a way, the obvious question which goes on in Java people's mind is, was this not better? Shouldn't it have been done like this, where I support multiple inheritance? And obviously the capability was there because it was already there for 7 years before that. And, okay. Now there is a reason why this is not done. You all know the reason? This is bad. Even C++ guys don't use it too much. Why? Because of the, what's the problem with this? Ambiguity errors, or what is called as the deadly diamond. You remember the deadly diamond? Okay, this is the deadly diamond. I'll tell you why C++ guys, while on base level this feature looks exciting, why it is a problem. So you have a base class A. Let's say I have a method M1 here. From A there is B and C, and there is D, and D is inheriting from B and C, and on D I say DD is equal to new D, and then on D dot M1 I say D dot M1. What happens now? Okay, this is star, because we are using C++, you use a pointer when you use a new. So, and D, you don't say, you have to say arrow, right? If you are in C++, you have to use this notation, dm1. This is how I do it. What is the problem now? Problem is now C++ says, oh my God, I know there is an M1, but I don't know whether B should get the M1 from A or C should get the M1 from A. Who's M1? Or there may be M1 in B and C both. Again, this is the same situation, what I am showing. B is getting one M1 by inheritance, C is getting another M1 by inheritance. Both are same, but C++ doesn't know that. C++ says which M1 should I get, right? And therefore this is called the deadly diamond. Right? No, yes. This deadly diamond is a reason C++ says now a deadly diamond can form any time, because when you inherit from one class, from a bunch of classes, at some point in their inheritance tree, if these classes are inheriting from a common class, then deadly diamond, here I am showing a very trivial case where a deadly diamond is happening right there. Imagine B inherits from something, C inherits from something, that something inherits from something, and at some other point in the hierarchy, there is an intersection. So the deadly diamond can come at any point. You don't know, unless you know the genealogy of every class that you are inheriting, you don't know whether you are going to have a deadly diamond problem or not. And that is creates a lot of trouble. So there are a lot of C++ people, lot of experienced C++ people who say this multiple inheritance is a good thing, but you know what? It can lead me to trouble, it can get me into a soup today or tomorrow, because I don't know which class inheritance will suddenly collide and have an intersection somewhere. At that point the ambiguity will come and the whole code breaks, right? So you have to then sit down again, rewrite your code, work from the bottom up, patiently spend few hours thinking it through, sorting it out, which is completely unproductive use of time, because the reason it happened was not your problem. The reason it happened was because the language permitted that to happen, and the language was not careful to block it or stop it or avoid it. Java said, no, we don't want this. We don't want to implement multiple inheritance at all. We don't want to support the idea that a class can be derived from more than one classes. But then, obviously, people turned around and said, but you know what? I want the ability to have the behavior of class B and class C in class D. That's why I'm looking for inheritance. How you are saying, okay, I don't support it. But then how will you enable this to happen? Something like that to happen. Are you getting me? Are you just going to say, I cannot extend from B and C, I can extend from only one and be done with it? Okay. You getting me? That obviously is not acceptable. I want something which B has, I want something which C has, I want something which E has, I want all of them. But don't make me write that code. I want to inherit. Show me a way. You getting me? Just don't say, I don't support inheritance, multiple inheritance. You can extend from one of them and forget about everything else. So now we talk about how do we actually put this in practice. Okay, now this is where it gets a little tricky and sticky. Okay, the way it works is like this. Now listen carefully. There is a class B I like, class C which I like, class D which I like, class E which I like. These are all four classes I like. Okay, I like means there is something in that. It's not just a question of liking, right? There is something in those classes which I want. Okay, so from B I like these two methods, M1 and M2. From C, I like these methods, M3, M4. D, I like these two methods, M5, M6. E, I like these methods, M7, M8. So, the way this would be created is, rather than these being classes, they will be interfaces, the commonality. So, let's call this interface I1, I2, I3, I4. Okay. So, class B, because it provides this functionality, class B will say, class B implements I1 and it will provide the logic for M1, whatever the logic is, and it will provide the logic for M2, whatever the logic is. So that is class B. This will be interface I2. Similarly, and I don't have to, I think, write all that, class C will implement I2. So by implementing I2, it will provide logic for M3, M4, and so on. Okay. So class D similarly will implement I3, class E will implement I4. Okay. Okay. Now have all of you grasped this? First, the common functionality which is very good in B, I will have to abstract it out as an interface. So class B implements interface I1, class C implements interface I2, and so on. So 4 different classes are providing that functionality, but that functionality has been abstracted out in the form of an interface. So how many interfaces do I have now? 4. Right? Now I am going to create a class X, okay, class KMIT, let's say, and class KMIT wants all 4 behaviors. Behavior of I1, I2, I3, I4, which is all sitting in where? One is sitting in class B, one is sitting in class C, so on and so forth, like this. So how will I design this special class which wants to have all this behavior? Okay. So the way I would do it is, okay, I would say class KMIT, I am just making that class, implements I1, I2, I3, I4. Now you will notice something important. While Java says you can extend only one class, Java doesn't say you can implement only one interface. Java allows you to implement as many interfaces as you want. Java says when you derive from only one class. There we will not permit multiple inheritance. But if you want to implement any number of interfaces, you can implement any number. So class KMIT is now going to implement all these 4 interfaces. And please remember, there is class B, class C, class D, class E, which have all these behaviors, one at a time, right? So what will class KMIT do? It will not implement everything. Otherwise, if it is implementing, it is like saying, I have to provide code. If I have to provide code, then everything is lost, right? I know I1 comes from B, I2 comes from C, I3 comes from D, I4 comes from E, whatever, something. Now, what will I do? I will say, I will create an instance of B. So, look at it like this, okay. So, KMIT has an M1, but this M1 comes from whom? New B dot M1. He implements M2, but that M2 comes from where? New B dot M2. Similarly, M3 comes from where? New C dot M3 on me, you can call M4 on me. But you know what I will do? I will not implement any of these. I will do, this in computer science is a very famous idea. This is called delegation. You know what is delegation? Delegation means I will not do it. Who will do it? I will hand it over somebody. You do it. You do it. You do it. I will not do. I am only a broker. I am only a coordinator. I am implementing to the world all these 4 interfaces. That means to the world I am appearing as if I am implementing 8 methods. Am I really doing 8 methods? No. How am I getting those 8 methods behavior? By a simple idea of delegation. I am saying, I don't know how to do M1. I neither know how to do M2. But I know Mr. B knows. So what will I do? I will say, create an instance of B, hand over M1 to that guy. Create an instance of B, hand over M2 to that guy. M3, do you know how to do M3? No. But I know C has M3. I will say new C, hand over M3 to him. So whenever somebody calls M3 on me, I am not doing anything. I am handing over to C. You do M3. But to the world, how am I appearing? From a protocol perspective, I am appearing as if I am capable of doing all the methods. Am I doing anything? No. I am delegating. So, now, is this really classic inheritance? No. I am not inheriting. This, if you look from a pure perspective, it is not inheritance. But, if you look from another perspective, am I showing all the behaviors? Yes. Am I implementing all the behaviors? No. I am kind of delegating. I am not directly implementing. This is not pure multiple inheritance. Please don't misunderstand here. This is like fooling the world into thinking I am having this behavior, but actually I am not having any of this behavior. I am handing over. So this is not inheritance. You can say this is an apology of an inheritance. But to the world I am appearing as if I am implementing all 8 methods, some from I1, I2, I3, I4. When James Gosling was asked, how will you do multiple inheritance which Java gives, which C++ gives, he said, I will use the delegation model. This is called the delegation model. Now, again I am saying, this is not pure inheritance. If you really understand inheritance, this is an apology, right? But to make it appear, it does appear as if, because see, net effect is what? Are you having all the 8 behaviors as KMIT? I am having all the. Are you doing them? No. Are you getting them done? Yes. How does it matter whether you are doing or somebody else is doing, as long as you are exhibiting those behaviors, right? So this is called the idea of delegation. Look, from a pure inheritance or multiple inheritance, because I am in a way putting the body for M1. Somebody will also say, for implementing just these 4 behaviors, you are creating 4 objects extra. Correct? Or maybe here, as I have shown, 8 objects, which is too much. But then this is how it works. This is called delegation model. Why is it called delegation? Because I am not doing it. I am handing over to somebody to do it. But that somebody had to be created, because I don't have that behavior. So, and to the outside world appears as if I am implementing all the 4 interfaces. So, what the argument Java people gave is, that is why we are not restricting how many interfaces you implement. You can show any number of behaviors, but you don't do those behaviors, you delegate. Okay? This is how it works. So, okay. So I think after this it will get a little heavy. So we will stop our conceptual. See, I have just introduced the idea of an interface. Now there are some more concepts. The concept of a final class, static class, which will come. There are a lot of fundamental ideas of Java which are there. Now let's do a bit of coding. Now I'll explain what to do, then you do. Okay, we'll start with the license plate problem. Okay, just open it. Now first read the question, then I'll elaborate. I think now we can explain. I'll briefly talk about that application. Okay, given a string, and please don't copy this from somewhere, copy code. Don't do that. Okay, let's understand the application. You have a string called license plate and an array of string words. So you have 2 things. Find the shortest completing word in words. So let me go to the example straight away. Okay, you have a license plate called LS3, 1S3 PST. So what you have to do first is, you have to get what the meaningful characters are, removing the numbers and spaces. So if you remove the numbers and spaces and whatever else other than letters, you will get a string SPS, that is 2 S's and 1 P. That is what you will get. Okay, once you get that, which you can store in a hash map or something, I will show you how to work with that. And then you have all those words. Now, is step going to match that? No, it's not going to match, because step has 1 S, 1 P and 1 T. Case doesn't matter. This should be there. Okay. So there should be two S's, one P and one T. Okay. So step has one S, one T, one P. Doesn't have two S's. Steps matches. Okay, that is way. Okay, next go down, right? Stripe, no, because it doesn't have two S's, one P and one T. No, it doesn't have. Stepple, two S it doesn't have. So how will you do this? So for every word, the original word and every other word, you have to maintain what is called as a hash map. What does hash map consist of? Key value. Okay, now before you do this example, I think because this example, or what is the other way to do it? Well, what you can do is, there is another way of doing it without using hash map, I think. Okay, now you collect all the meaningful words and convert that into a sentence. So P is uppercase, 1 S P 3. Okay, something like this. There may be spaces in between which you have to ignore. So this string will become S, S, T and P. If you convert everything to lowercase, you will get P. Now you can sort it. Okay, you can sort it. If you sort it, it will become P, S. If you sort this string, figure out how to sort a string. You can sort a string. Okay, go to Google, find out how to sort a. First take every letter, concatenate into a string, convert that string to lowercase. Okay, you will get this. Now you have one by one, you go through this steps. Take step. Okay, if you do step, then if you sort it, you will get E, P, S, T, E, P, S, T. Now, what has to happen is, now you have a P, S, S, T and E, P, S, T. I think it may not help to do that. Okay, now you can take, you don't need to sort this. I think this, if you have sorted it and kept it, it's fine. You go through each one. Now take this as your I goes through this, J goes through this. So, no, but then you will miss the double. I think you will have to use hash map. So, if I create a hash map of this, okay, where key is character and this is T, this is frequency, you will get P1, S2, T1. Okay, you will get this. Now, in this, you will get for step, you will get, or you can go through this S, and I don't know whether you should create another hash map, or you can, well, you can create a hash map of this and compare entry to entry, whether this hash map is same as that. But it need not be same, it can be a subset of that. As long as these are there that many times, we are fine. So you can do one more thing. You see how many times this is there? One thing you can do is, P has to occur at least one time, S has to occur these many times, T has to occur one time. So you can say find and see how many times. There is count also, no? Yes. Java count is there. This is occurring in there. Is count method there on string? Okay, let's just see is a count method, because that will come very useful. Count on string. It may have been added. No, I think you have to write it on your own. Okay, let's see how many of you can do. This is how you count the presence of a character in a string. It should occur the same time. I'll pause. Let's see how many of you can make progress. Don't copy. Struggle a bit on your own and do it. Let's look at the way the input is given. Okay, let's look at the input. The first line of the input gives the text and the thing which you are going to look for, and which is what they call the license plate, and then to which words does it match. Okay, so now I hope you are understanding the first input and the first output. See, in the first input there is 1 S3 4 5 6. So is that all? All the words which contain, but among these which are the shortest, and among the shortest it appears the earliest. Okay, so that is why you are giving pest. Okay, that is the way to select and match. Okay, so you have to go from beginning to end and find out which is the word which is matching, and find out, keep its length. So whatever is the length you do. So we'll do it using basically loop only. Okay, no hash map, no nothing. We'll write 2 loops and do it. So first what we'll have to do is, we'll have to, okay, class test. So let's start writing it. Okay, public. So now the first thing we'll do is, we'll read the first string. How do we read the first string? Because the first string can have blanks, the first line. We have to use not next, but we have to use next line. So we'll create the scanner. Scanner SC is equal to new scanner. Okay, new scanner system.in. Then we will say string input, now call it input, is equal to sc dot next line. Okay. Okay. Now we'll go through the string and pick up what all? Pick up all characters, okay, which are characters, which are not numbers or anything. So anything which is in the ASCII uppercase or ASCII lowercase will pick up. So we'll go through this string input for, okay, first let's create an empty string, which is what we are going to use. So we'll call that license plate, LP, our version of the license plate, equal to empty string. Okay. Now we'll go through input for each equal to 0, I less than input dot length. Remember, every string has a length method. No, length is a method. If it's an array, length is a variable. So I plus plus. We are going through the input string. Now what do we do when we are going through the input string? So for int I equal to 0, I less than input dot length, I plus plus. What will I do? I'll go through that string and check whether the string has character or not. Now, how do I do that? There are 2 ways of doing it. Okay, let's see one way of doing it. I'll retrieve the character, char C is equal to, what will I say? Input dot char at I retrieve that character. Now I have to check whether the range of the character is in the ASCII range or not. So how will I do that? If C greater than or equal to, it's uppercase or lowercase, then I'll convert it into lowercase and add it to my result, LP. So what will I check? If C is greater than or equal to 97, correct? No, it is read as character, right? So it cannot be 97. So if C is greater than or equal to small a and C less than or equal to small z, either this or it's in this range, No, you put this so that that check is independent. Or C is greater than or equal to capital A and C is less than or equal to capital Z. If any one of this is there, then we'll add that character to our license plate string. So we are removing everything which is non-character. So LP is equal to LP plus C. Okay. Then once we are done with this, are all of you understanding what's happening? This is how you should think of, you know how to write a for loop, you know how to write a string manipulation, how to go through a string. So this is how you go through a string. For int I equal to 0, input dot length I plus plus, I am retrieving one character at a time, char C is equal to input dot char at I. Then I am checking whether the character is a ASCII character or not, uppercase or lowercase. If it is, then I am concatenating it into LP. Now LP may have lowercase or uppercase, okay. So now I come out of the for loop and I say LP is equal to, now how do I convert a string into lowercase? There is a nice function called toLower. How do I call it? LP dot toLower, I think, right? How do you call it? Check, no? LP dot to lowercase, semicolon. So now what have I got? I have got the string in lowercase. Agreed? No. If you want, you can do a SOP at this stage and check whether the string is correctly coming or not. Let's do that. System.out.println. Let's just test this part of the program, okay? Just to see whether we are getting correctly. LP. Okay. So let's run it and check. Okay, let's give a string 1P. 1S3 PST. Okay. Okay. Now it seems to be working fine. This is what we wanted, isn't it? No, yes. See, I gave a string 1S3 space PST and it gave me nicely SP lowercase st. It gave me all of that. Now I have a nice string. Now what I have to do? I have to compare this license plate string with each of my words, okay, in one by one. And first one matches. If it matches, that is it has all the words, then what should I do? Then I have to say this as the the matching string, but I have to remember its size. Yes, no? I have to remember two things. What is the matching string and what is its size? So if I have a matching string which is smaller, then that matching string will qualify. Okay? If I have a smaller. So you have to write that code. Now, before that, before we go through the words, wait. Before line 14, on line 14, we'll remove the system.out.println and we'll create two variables. One a matching string. Matching means matching our pattern. So string, match string, matching string, M string, let's call it M string, matching string, and equal to, right now, empty. And because we want to find the smallest at any given time, we have to always assign it to a high value. So int min min or min length, m length is equal to 9999, because anything comes, it should be smaller. Okay. Now, so do you understand why I created these two variables? They are ABCD of coding. I created an m string blank matching string and an m length. I have created these two. Okay. So now what should I do? Now I will go and stretch it, or I will go and alter it. So now I have to write a loop. Okay. So for, how should I write the loop? Now every character of S, okay, I have to match to see if it is occurring in that other string, and then we'll have to compare. Now, okay, so first we have to split our second string into SARR. Yeah, we have not read it also. Okay, we have to read that array. No, you can read now also. Doesn't matter. We have to read the array of. So we have to say string line 17, string words is equal to sc dot next line split on space. This will give us all the words which we have to check against the license plate, against LP. Okay. Now we have set the abstract class. We have set the, whether you can complete it. Okay. I'll stop here, but I'll continue with this in the next session. But if you can complete and continue and complete, fantastic. You know what you need to do? You need to go through LP character by character and look for that character in that string, but not look. Count should be the same. If there are two S's, there should be two S's here. So if I were in your place, I would write a nice count function. It is not there, but it's available on the internet. Borrow that count function, count to count how many times a character is there in a string. In Python and all, we have ready-made that given a string, we can straight away say how many times this character occurs in that string. Now in Java we don't. So we have to write that function and use it. Okay. So we'll continue with it in the next session.